We are solving numerical problem related to the chapter 4 of class 10 and we are preparing for SE examination. In last class I told you 5 equations which are used to solve the numerical problem related to the force. Out of those 5 equations, first equation was used in last class. I am going to use now second equation to solve another numerical problem. Look at this. These are the equation which we are going to use in numerical problem. This is used in previous class. Now I am using this equation to solve the numerical problem. Look at this problem. A man of 100 kg stands on the surface of the earth which has 6 into 10 to the power 24 kg mass. If the radius of the earth is 6400 km, then calculate the gravitational force between them. And value of G is given. G is 6.67 into 10 to the power minus 11 Newton meter squared by kg square. Looking at the numerical, sometimes you feel difficult how to solve this numerical, but when we write the mathematical information given in the numerical problem, then the same problem becomes very easy. Look at this, how to write. The first one, the mass of man 100 kg is given. I am taking symbol for mass of man as small m and mass of the earth as capital M. Why not M1 and M2? In comparison with the huge earth, mass of a person is very less, and that's why we are using capital M for bigger mass and small m for small mass. Okay, mass of man M is given how much? 100 kilogram. And mass of the earth is given how much it is? 6 into 10 to the power 24 kilogram. And radius of the earth is taken as R is equal to how much? 6400 kilometer. Now this time, instead of writing further, I am going to solve this. I am going to convert this kilometer into meter because we are using SI system. In SI system, we are using meter as the unit of distance, and this was kilometer. 6400 kilometer can be converted into meter by multiplying it with 1000, and it comes in meter. This is equal to 6400. Again 30 we have. And this is meter. This much big number is usually not used in the numerical problem. I want to convert it into 10 to the power something. Look at this. Here we have decimal point. If this decimal point is shifted to this place, we can write 6.4. And after 4 there are 0 only. That's why I want to ignore this. And how many digits? The decimal point is shifted 1, 2, 3, 4, 5, 6 digits. That's why I have to multiply it with 10 to the power 6 and it came in meter. This way I taught this in previous class also. This big number usually not used, and the number is shortened this way. Okay, now next, G is given. That's why I am writing G. G is equal to 6.67 into 10 to the power minus 11 Newton meter square by kg square. And the question is, look at the question is, calculate the gravitational force, and it is denoted by F. F is question mark. Now this numerical problem is now converted to mathematical form. Now we don't have to see this numerical problem. Looking at this, we can select the equation and we can use the equation. M is given, R is given, G is given, F is given. F is the question. Now look at this. Here we have F is question, G is given, and M is also given, and small m is also given, and R is also given. That's why we are using this second equation to solve the numerical problem. So we have F equal to capital G, capital M, small m by R square. This is equal to G. Value of G is 6.67 into 10 to the power minus 11. If you want to write unit, you can write unit, but without writing the unit we can solve numerical problem. But when answer comes, at that time we have to write unit. G, 6.67 into 10 to the power minus 11. I am not writing unit at this time. Capital M, its value is 6 into 10 to the power 24, and small m, its value is 100, and R, how much is R? 6.4. 6.4 into 10 to the power 6, and R square means this is square. Now this is equal to, see, if we have to go through this 10 to the power and number, then I suggested in previous class also we have to write first the numbers 6.67 into 6, and then we are writing power of 10, 10 to the power minus 11 into 10 to the power 24. This can also be written in power of 10, 10 to the power 2, 1 having 2 0. Now after this, 6.4 into 10 to the power 6 whole square means we can write this twice. 6.4 into 10 to the power 6. Okay, now it's time to use calculator. 6.67 into 6. 6.67 into 6. This is equal to 40.02. 40.02 into 10 to the power minus 11. If we have same base, then power can be added to each other, plus 24 plus 2. Now here again 6.4 into 6.4, we can multiply directly. 6.4 into 6.4, 6.4 into 6.4, this is equal to 40.96. 40.96 and multiply by 10 to the power 6 into 10 to the power 6. Same base, that's why 6 plus 6, 12. Okay. Now next, look at this. 40.02 divided by 40.96. 40.02 divided by 40.96. This is equal to 0.977050. 0.9705, and after this let it be 0.97705. Again I am writing 0.97705 multiplied by 10 to the power 11 plus 24 plus 2. 24 plus 2, 26. 26 minus 11 becomes 10 to the power 15, and in denominator we have how much? 10 to the power 12. Now I am doing here. Now it is f is equal to 0.97705 into 10 to the power 15. 10 to the power 15, and if 10 to the power 12 is taken in numerator, 10 to the power minus 12, or f is equal to 0.97705 into 10 to the power 15 minus 12, or f is equal to 0.97705 into 10 to the power 3. 10 to the power 3 means 1000. If we multiply this number with 1000, then it's very easy. We can use a calculator also. 977.05, and unit of force, gravitational force, is what? Newton. This is our last answer. This way we can solve numerical problem. I want to show you one book where all these numerical problems are solved. This is Enjoy Science, and here these numerical problems are solved, and a little tough numerical problem is also given. If you want to enjoy this, you can get it from market. Next class we'll continue with another equation. Thank you.